This week we are going to cover analysis of variance, normally referred to as ANOVA. ANOVA falls into a broad category of statistics called inferential statistics. The other category of statistics is called descriptive statistics, and it's what we covered in the last chapter. So inferential statistics usually give a general conclusion about data based on the analysis of a sample. The conclusion is usually done with respect to 5% level of significance, normally 0.05. So for one to conduct ANOVA, two assumptions must be met. One of the assumptions is that the data must be normal, the dependent variable must be normal, and the other assumption is that the dependent variable must have a uniform variables with respect to the various groups that are there. So ANOVA basically compares the means of two or more groups. So for instance, if you want to know whether the performance in mathematics of male and female students in a class is statistically different or not, then you use ANOVA. If you want to know whether the height of male and female students or groups of individuals is equal or not, then you use ANOVA. So in this week tutorial, we're going to use this data set. So in this data set, basically you want to know whether the residence, whether it affects the electricity consumption of that individual. So this sample was selected from cities in Australia, and the cities were Adelaide, Hobart, Melbourne and Perth. So you want to know whether individuals who stay in these cities spend differently on their electricity. So you get the electricity consumption of 25 households in each of these 4 cities, and use ANOVA to check whether they are equal or not. So like I said before, for ANOVA to be valid, then first thing that must be certified is that the dependent variable, which in our case is the cost of electricity consumption, should be normal. And if you want to know whether a variable is normal, you go to analyze, you go to descriptives, and then you go to explore, and then you ensure that the dependent variable is in the dependent list, and then you click on plots, and then you make sure that the normality plots with test is checked, and then you click on continue, and then you click on OK. So down here you're going to have this table that is a table on that presents the test of normality, and it usually use the Shapiro-Wilk statistic to test. So if the significance level is greater than 0.05, like in our case it's 0.11, then we conclude that the data is normally distributed, and so ANOVA test is valid to be conducted. So now that we've confirmed that it's valid, let's proceed and do the actual analysis of variance. So if you want to conduct analysis of variance, you click on analyze, and then you go to compare means, and then one way ANOVA. So the dependent variable is the cost of electricity. You push it to the dependent list, and then the city of residence is the independent variable. You push it to the factor. So you go to options, you check the homogeneity of variance. This is the other assumption that you want to check, whether the variances of the cost of electricity in the various towns is the various cities is uniform or homogeneous. You check on that, and you check on descriptive just to know the general characteristics of the data, and then you click on continue, hit on post hoc, and then you click on Turkey, click on LSD, click on continue, and then you click on OK. So once you've done that, this is what comes out. You're going to the first table is the descriptives. You see the number of cases. They had 25 households in Adelaide, it had 25 households in Hobart, 25 households in Melbourne, 25 households in Perth. The total comes to 100. the mean electricity consumption for Adelaide is 497.28, for Hobart is 515.84, and for Melbourne is 531.2, and for Perth is 555.12. So this other column provides the variation in terms of standard deviation, and then this other column presents the standard error, which is basically the standard deviation of the sample. This other column here is the confidence interval, the lower bound and the upper bound, and then this other column is the minimum for that group of data and the maximum value. And then this second table shows the homogeneity of variance test, and usually conducted by Levin's statistic test. So if the significance here is greater than 0.05, then we conclude that the dependent variable, which in our case is cost of electricity and gas, is homogeneous with respect to the various cities. So it means that the variance of the cost of electricity of the 25 households in Adelaide, the variance of cost of electricity in the 25 households in Hobart, the variance of cost of electricity in Melbourne, and the variance of the 25 households for the cost of electricity and gas in Perth is uniform. So that means conducting analysis of variance test is valid now that we've confirmed that the variances are homogeneous, and we had confirmed earlier that the dependent variable, which is the cost of electricity, was uniformly distributed. So this third table here is now the actual analysis of variance table, and we look at the significance level here again, and you find that it's 0.13. So you compare that with 0.05, and you find that it's less than 0.05. So in this case now it means that we conclude that there is a difference in electricity consumption in two or more of the various cities that are under study. So you look at the multiple comparison here. So in this multiple comparison, basically we get to know which cities have a significant difference, so if you want to know the cities that have a significant difference, you look at this column of significance here. So the significance that is less than 0.05, then those two cities have a difference in their electricity consumption. For instance, here we have significance of 0.008. So a significance of 0.08 is less than 0.05, and that means that Perth, the city of Perth and the city of Adelaide have a significantly different electricity consumption. The other city that has a significantly different electricity consumption is this one here, the significance 0.02, which is less than 0.05. So this means that Perth and Adelaide, as we had seen, have a significantly different electricity consumption. The other one is here, which is less than 0.029, which is less than 0.05. It means that Hobart and Perth also have significantly different levels of electricity consumption, and these two here, which we had looked at, so Perth and Adelaide and Perth and Hobart, those two have significantly different levels of electricity consumption. So like I had said before, analysis can't end at the output of SPSS, so you need to transfer these tables to a convenient word processing program like Microsoft Word. So click on Microsoft Word. So once you're there, come back, you select the tables that you want to report. Most important will be this one. You copy it and then you paste it there. You leave space for reporting. You go back, you take the other tables that you feel will be important for reporting, just to, like, this one will be important to know the cities that have significantly different levels of electricity consumption. You paste it, and then don't let any table overlap, so you make sure it's completely fitting like that. So, and the homogeneity test, you paste it there, and then probably you also take the test for the normality test, and you paste it there. So you can go ahead and save this document for further reporting. Like in our case, we'll save it on the desktop. You click on File, Save As, then you go to the desktop, give it a convenient name like Anova, and then you save. So I believe now you can comfortably analyze analysis of variance using SPSS. Once you have data, you basically just check whether the assumptions have been met of normality and homogeneity of variance, and then you proceed with the test. So thank you for watching, and see you next time in the next unit. Thank you.